Hi there students. In the previous module we discussed about definition of locus, the equation of locus and the steps to find equation of locus. Now in this module we will discuss about distances, the types of distances and the problems based on finding equation of locus using distances. Now without further ado, let's get on into the module. Talking about distances. Now remember you all, in coordinate geometry, there are three different kinds of distances. One is the distance between 2 points. Second is the distance between a point and a line. And the third is the distance between two lines. So let us discuss about distance between 2 points first. Now suppose that we have 2 points, ax1 y1 and bx2 y2, and we have to find ab, that is distance between x1 y1 and x2 y2. We can find this distance as root of x1 minus x2 the whole square plus y1 minus y2 the whole square. Now here it is fine if we use x2 minus x1 and y2 minus y1 instead of x1 minus x2 and y1 minus y2. It's all the same because it's going to get squared. It's going to be the same ultimately. Anyway, moving further, so whenever we need to find distance between 2 points, we'll always use the formula root of x1 minus x2 the whole square plus y1 minus y2 the whole square. We also call this formula as the distance formula. Now let us move forward to the next concept, distance between a point and a line. So students, we are just going to have a glance over this concept. We are not going in detail because this concept will be talked and discussed thoroughly in a chapter called straight lines, which is your next chapter. Alright, having said so, getting into the concept, to find distance between a point and a line, we will obviously need a point and a line. So let x1, y1 be a point A and let there be a line whose equation is ax plus by plus c equal to 0. Now let d be the distance of the point ax1, y1 from the line. Now remember students, distances are always perpendicular. Then we can find the distance d by the formula d equal to mod of ax1 plus by1 plus c upon root of a square plus b square. Now, how do you remember this? This can be very easily remembered by keeping this in mind that in the numerator of RHS, we have simply substituted x1, y1, that is a point in the equation of line. And the denominator of the RHS, we have taken square root of x ka coefficient ka square plus y ka coefficient ka square. Now guys, this formula is also known as perpendicular distance formula. Moving further to the next concept, distance between two lines. Again, for this concept also, we'll just barely touch the topic because this will be discussed in detail in straight lines. Now remember you guys, if we need to find the distance between two lines, then both the lines should be parallel to each other. Otherwise, we won't be able to find the distance between them. Also remember this, that if ax plus by plus c1 equal to 0 is the equation of a line, then the equation of a line parallel to this line can be reduced and written in the form of ax plus by plus c2 equal to 0. Now in these equations, what is it that you observe? Yes, the first thing that you observe is the coefficient of x in both the equation is a. Similarly, the second thing is that coefficient of y in both the equations is b. And third, you observe that the constant in the first equation is c1, but the constant in the second equation is c2. So by looking at these 3 points, we can conclude that for two parallel lines, their equations will only differ in their constant terms. Means every term will be the same except for their constant terms. So let us consider two parallel lines, ax plus by plus c1 equal to 0 and ax plus by plus c2 equal to 0. Let d be the distance between these two parallel lines. Again, distance, so perpendicular. Then distance between the two parallel lines is calculated by the formula d equal to mod of c1 minus c2 upon root of a square plus b square. Now, let us again revise this topic. Whenever in coordinate geometry, not just in locus students, but whenever in coordinate geometry you talk about distance, your mind should automatically say there are three choices to find distance. First one is the distance between 2 points. We use the formula d equal to under root of x1 minus x2 the whole square plus y1 minus y2 the whole square. We also call this as distance formula. The second is the distance between one point and one line. We use the formula d equal to mod of ax1 plus by1 plus c upon root of a square plus b square. Also, this formula is known as perpendicular distance formula. Then we have distance between two parallel lines, whose formula is given by d equal to mod of c1 minus c2 upon root of a square plus b square. I hope you will remember this in time to come. So guys, let us move to the next concept, that is distance of a point from the coordinate axis, which means distance of a point from x-axis and the distance of a point from y-axis. So for that, let us consider a rectangular coordinate system, that is x-axis, y-axis and an origin. Now let us plot a point a3, 1 on this system. And how do we do that? First, we will go 3 units distance on the x-axis. This point is 3, 0. Then we will go 1 unit distance on y-axis. This is 0, 1. Draw perpendicular from 3, 0. Draw perpendicular from 0, 1. The point where these perpendicular meets is a point 3, 1. Okay, now before you think कि ये क्या सड़ा रहा है, ये तो अपने को पता है, स्कूल में भी करते थे. I know, you people used to do in school, I know that. But the thing is, I need this for the next concept. Now, having said so, recall how you plotted 3, 1. Similarly, we have to plot a point ph, k on this system. Now, how do we do that? On the x-axis, we'll cover a distance h, plot h, 0. On the y-axis, we'll cover a distance k and plot 0, k. We'll draw perpendicular from h, 0, draw perpendicular from 0, k. And the point where these two perpendiculars intersect, that point is h, k. Now students, observe here. This is a rectangle, which means opposite sides are equal in length, right? So if this distance is h, then this distance is also h. If this distance is k, then this distance is also k. Now look here. Observe only this part, this distance. This distance is nothing but distance of point from x-axis. So we can say distance of point h, k from x-axis equal to k. Since the distance is positive, so a modulus sign. Now, what is k? The y-coordinate of h, k, right? So we can generalize that distance of a point from x-axis equal to mod of y-coordinate of that point. Now let us observe this part, this distance. This distance is nothing but distance of point from y-axis. Therefore, distance of point from y-axis equal to h. Now, since the distance is positive, therefore a modulus sign. But what is h? Yes, the x-coordinate of point. So we can generalize and say distance of point from y-axis equal to mod of x-coordinate of that point. Once again, to summarize, distance of point from x-axis equal to mod of y-coordinate of the point, and distance of point from y-axis equal to mod of x-coordinate of the point. Good job, guys. Now, in the previous module, that is the first module of locus, we discussed about the steps to find equation of locus. Let us revise that first. So, whenever we have to find equation of locus, what should you remember? Your brain must automatically say that there are 4 steps to find equation of locus. Now, what were those 4 steps? The first step said you need to assume a point h, k on the locus whose equation is to be found. The second step says that using the geometrical condition given, you need to form an equation in terms of h and k. The third step, which is also an optional step, is to eliminate all variables other than h and k. And finally, the fourth step is to generalize the equation thus obtained by replacing h and k with x and y respectively, and you will get equation of locus. It's as simple as that. Now, let us revise today's topic also. Now, when it comes to distance, what is it that you should recall? Right, there are 3 choices to find distances. Number 1 is the distance between 2 points, where we use d equal to root of x1 minus x to the whole square plus y1 minus y to the whole square. This is also known as distance formula. Second was distance between one point and one line, where you use the formula d equal to mod of ax1 plus by1 plus c upon root of a square plus b square, which is also known as perpendicular distance formula. And the third one was distance between two parallel lines, where we use d equal to mod of c1 minus c2 upon root of a square plus b square. Also, we saw that distance of point from x-axis equal to mod of y-coordinate of the point, and distance of point from y-axis equal to mod of x-coordinate of the point. Excellent. So let us start with the problems. The first type of problems, that is the problems based on distances to find equation of locus. So the question says, find the locus of point P if the distance of P from x-axis equals 10 times this distance from y-axis. Look at the question. What is it that you have to find? Yes, you have to find equation of locus. And whenever the question is to find equation of locus, what is it that you must think? Your brain should automatically say there are 4 steps to find equation of locus. What is the first step? The first step is to assume a point h, k on the locus whose equation is to be found. So in the question, it is asked to find equation of locus of point P. So we say let P h, k be a point on the required locus. This is your first step. Now that the first step is over, what is your second step? Your second step is to form an equation in terms of h and k using the given geometrical condition. Now look at the question, pause the video for a moment and try to guess what is the geometrical condition given. Okay, so let me just highlight the geometrical condition for you. The geometrical condition is distance of P from x-axis equals 10 times its distance from y-axis. Now, the first part of this condition says distance of P from x-axis. We already discussed in this module that distance of point from x-axis equal to mod of y-coordinate of the point. So here in this question, distance of P from x-axis will be mod of y-coordinate of P. That means mod of k equals to 10 times. So equal to 10. Distance from y-axis. Again, we saw in this module distance of point from y-axis equal to mod of x-coordinate of the point. So in this question, distance of P from y-axis will be mod of x-coordinate of P. That means mod of h. Superb. So this is our geometrical condition. Mod of k equal to 10 times mod of h. Now to simplify, I'll shift mod of k to the other side. So this becomes 10 times mod of h minus mod of k equal to 0. Thus, our second step is over. Now for the third step. Third step says you need to eliminate all variables other than h and k. Now go back to the equation. Now, do you find any variable other than h and k in this equation? No, the equation is 10 times mod of h minus mod of k equal to 0. So there is no variable other than h and k. So we don't have to use our third step. So let us go to the fourth and the final step. The final step says that we need to generalize the equation by replacing h and k with x and y respectively. So we can say in general, equation of the required locus is 10 times mod of x minus mod of y equal to 0. So this is the required locus. I hope you are pretty clear with this problem. If yes, then let's take one more sum. So in this problem, the question says that find the locus of P if the distance of P from origin equals 5 times its distance from 3, minus 2. So what do we have to find? We need to find equation of locus. What should you think? That there are 4 steps to find equation of locus. So the first step, we will assume a point h, k. So let's say let P h, k be a point on the required locus. Now students, always remember, in every question of locus, look in the question if they are talking about any point. If there is a point, then give a name to it and only then proceed to find the geometrical condition. So look at the given question. Are there any point there? Yes, there are in fact 2 points. One is the origin and the other is 3, minus 2. So let's name them. Let O be equivalent to 0, 0 and A be equivalent to 3, minus 2. Now let us move to the geometrical condition. So according to the given condition, what is the condition? Again, pause the video students. Try to guess it. Now let me just highlight the geometrical condition for you. So the geometrical condition is distance of P from origin equals 5 times distance of P from 3, minus 2. Now the first part of the condition, distance of P from origin, we'll denote it as OP. Next, equal 5 times. So we write equal to 5. Moving further, distance from 3, minus 2. And we named 3, minus 2 as capital A. So we will write AP. So our geometrical condition is ready to use. Let us just write down the coordinates of P, O, and A. They'll be useful later. Okay. Now coming back to our geometrical condition OP. What is OP? Distance between O and P. That is distance between 2 points. So guys, tell me, what are you going to use? Distance between 2 points means we'll use distance formula. Root of x1 minus x to the whole square plus y1 minus y to the whole square. Directly applying the values to this formula using the coordinates of ph, k and o0, 0, we'll get root of h minus 0 the whole square plus k minus 0 the whole square equal to 5 times. Now let us go to AP. What is AP? Distance between A and P. Again, distance between 2 points. Again, distance formula. That is root of h minus 3 the whole square plus k plus 2 the whole square. I hope this is clear to you. Now let us simplify them. For that, first we need to get rid of the square root signs. So squaring both the sides, we will get h minus 0 the whole square plus k minus 0 the whole square equal to square of 5, which is 25 times h minus 3 the whole square plus k plus 2 the whole square. Now h minus 0 is h, so h square plus k minus 0 is k, so k square equal to 25 times. Applying the formula of a minus b the whole square, we get h square minus 6h plus 9 plus k square plus 4k plus 4. Now by rearranging the terms in the RHS, we get h square plus k square equal to 25 times h square plus k square minus 6h plus 4k plus 13. Therefore, h square plus k square equal to, let us multiply 25 inside the bracket. So we get 25h square plus 25k square minus 130h plus 100k plus 325. Guys, this is 325. It went outside the screen, but this is 325. Okay. Now I will shift h square and k square to the other side. So we will get 25h square minus h square, that is 24h square, plus 25k square minus k square, that is 24k square, minus 130h plus 100k plus 325 equal to 0. We have a simplified geometrical condition here, guys. Again, in this equation, there are no extra variables. That is, there are no variables other than h and k. So we don't have to use the third step. So moving to the final step. The final step is to generalize the equation. So we'll write, in general, equation of the required locus is 24x square plus 24y square minus 130x plus 100y plus 325 equal to 0. So you see, that was easy. Now all the questions of locus are easy, guys. You just have to follow the steps mechanically. Trust me, coordinate geometry is very simple. You just have to remember the formulas. You need to remember the step, look at the questions for hints, follow the steps and get the answer. That's all. So we'll end this module over here, and it's been very lovely teaching you the concepts of locus, distances, problems based on it, and the next module we'll discuss some more problems of this type. So until the next time, see you again.